Hi everyone. So let's see the solution of the questions that we had in our DPP. So this is the first question. In this question, they are saying that there is a linear regression model, and the model is basically trained based on the dataset A and tested on the dataset B. Right now, they are saying if you are training on the dataset A, then definitely the line that you will be getting will be something like this. And now if you're testing and the pattern is basically same, the pattern is being followed. So if you're testing on B, then in that case the test error will also be the less, right? So train error is definitely less because you're training on the dataset A, and A is linearly visually you can easily see that it is having the linear representation. So that is why that is the reason that you will be having lesser train error and similarly lesser test error also. So what is the answer? I think C is the correct answer here. Okay, C is the correct answer. So C is the correct answer. Now let's see the same question, a different variation. Now they are saying you are training on combinedly A and B. Okay, you are training on combinedly A and B, and the testing on C. In that case, definitely the train error will be less. Okay, and the test error will be high. So C is the correct answer because after training you will be getting this. So on the test, obviously the C is basically following completely different pattern. So you will be getting something else when you test on C. So basically correct answer is again C. Okay, here is also C answer. So test error is basically high because you will be getting something like this. So test error is high. Now let's see this question. This was interesting question. In this question they are saying that you perform linear regression and then you are basically having the outliers, few large outliers you have. What does the outlier mean? So let me just tell you. See, let's suppose your whole data is like this, right? And then outlier will be basically something like this, something which is very different from the data, and then something like this. Okay, which means that if you train this model, then ultimately you will be getting something like this, and your outlier is far from this by cap, and this is y. I mean, this difference is quite high. Okay, this difference is quite high. That's what outlier mean. Now they are saying there are few large outliers are there. So which means if you have large outliers and if you have this kind of loss, which means squared loss, in that case, if this is, let's suppose this is 10, then by going square it will be 100, which means this distance is basically 100, and now this squared loss will try to make it as less as possible. So it will get influence from the outliers, which means it will try to rotate this line so such that it is near to the outlier, because it will give more importance to the outlier. If this loss is greater, then it is giving more importance to the outlier. So we want this to be lesser, not greater, right? So that is the reason we will not be using square loss. Instead of that, we can use the absolute loss. This is fine. Obviously power 4 is not good. Replace mean loss with total loss. It doesn't matter whether you are dividing by n or you are not dividing by n. I mean, mean means divide by n, total loss means doesn't divide by n. It doesn't make any difference. So this is wrong. Now they are saying minimize the maximum individual loss, which means you only focus on this. This is basically rubbish, right? I mean, only focus on the outliers. So this is also not good. So basically we want to have as less influence of outliers possible. So that's why we want the overall loss function to be like this, such that I can train, and at the same time I do not get influence with the outliers. So what is the answer? A is the correct answer. Okay. So in case of outliers, I can use absolute error instead of squared error. Okay. We have seen all of this in the course also. Now let's see this question. This question is related to softmax regression, binary logistic regression using the softmax function. They're asking what is the probability of y equal to 1 given x. Now you might remember that in softmax regression, what we used to do, we have x, then we have, if there are two classes, then we have w0 and w, I mean we have two weights basically. If there are two classes, we have two weights. Okay, if there are three classes, we have three weights, like that, right? In the softmax regression, since it is binary, that's why we have two classes only. That's why we have two weights only. So we calculate scores. Okay, these are called scores, z1, z2, or w0 x and w1 x, right? And then instead of directly using those scores, we convert those scores to the probabilities using the exponent function, right? And then we normalize. And these are the probability. This is probability of y being 0. This is probability of y being 1, right? These are the two probabilities. Now they are asking what is the probability of y being 1. So w1x will be here, and then this. So B is the correct answer. Okay. B is the correct answer. That's very easy. Now see, D could also be the correct, I think, if this is W1 minus W0. Okay, if this is W1 minus W0, then the D could also be the correct. Why? Because if you divide, let's suppose with the W0, right, then it will be W1 minus W0, and here also W1 minus W0. So currently D is not the correct answer, but if it is W1 minus W0, then B and D are same. Okay, in that case D is also correct, but currently D is not correct. So B is the only correct answer here. Okay, B is the only correct answer here. We have seen all of this in the lectures also, right? So this is softmax regression. Now let's just see this regularization question. So in this case, they're comparing L1 and L2. Now they are saying L1 uses the square shape constant region, L2 uses the circular shape constant region. So let's just first talk about B and D, okay, option B and D. You might remember that this is how their constant regions look like. Okay, this is L1, this is L2. Basically this is the sweet spot in the L1, this is the sweet spot in the L2. Okay, we have talked about this in the lectures. Basically this L1 is since it is diamond shape, so it is also, I mean, at the same time it is also basically encouraging some of the ways to be 0. For example, here the beta 1 is 0 and beta 2 is not 0. Okay, so it encourages, and there are multiple reasons also where by which L1 actually encourages loss to be I mean some of the ways to be 0 basically. Okay, but it uses the diamond shape, and L2 uses the square shape. So L1 uses the square shape, sorry, L2 uses the circular, yeah, diamond or square shape, this is correct, and L2 uses the circular, this is also correct, right? Now what about the other options? L1 regulation tend to produce the sparser weight. Yes, L1 basically try to make few weights to be exactly 0. Okay, L1 try to make few of the weights to be exactly 0. L1 regulation can be solved in closed form. See, L1 cannot be solved in closed form. Reason is that because L1 is not differentiable. For example, whatever the loss you have, let's suppose you have a squared loss or whatever, right? Then let's suppose you have L1, right? So you cannot solve. Okay, this is, let's suppose, the regularized loss. Let's suppose regularized loss is this. Okay, you generally cannot differentiate with respect to W. So that is why L1 is not having closed form solution. I mean, this is a mod of W, and it is not differentiable at W equal to 0. Not differentiable everywhere. Not differentiable. Okay, so L1 is not having closed form solution. So that is why you can say can we solve in closed form? This is wrong. So A, B and D are the correct answers. A, B and D are the correct answers. So yeah, so I think answers I have the answers. So A, B and D are the correct answers. Okay, so this was also a good question. So that's all about these 5 questions. Thank you everyone.